Hi everyone, welcome back. We continue on this lesson. Today we are going to learn about determinant function. This function is, you will remember from the math, which is widely used in linear algebra operations. Also at the same time, this is widely used in image processing operations. Since we are dealing with matrices, it's normal, right? And that's why OpenCV included this function to its library. And today we are going to learn how this function is working. Also how we can use this in image processing operations. And usage is very simple. Basically, you're just giving your input math and it's gonna give you the output in the double type. But the critical point, maybe you should remember, the image type should be in the float type, and also it should be 32-bit or 64-bit. It should be okay. Just remember that the input should be in float type, otherwise it's gonna give you error. Maybe we can switch to the code part and continue on here. Okay, this is from the previous video. We can remove these parts. Also, I want to show you another method of how to assign pixel values into a math. Normally we were using this method, which is your declaration.add, which is the type of the image, and you are specifying the coordinate and the value of pixel at the end. So it was assigning your pixel value into the image. Okay. But for this one, I want to show you a different method. Just opening parentheses and calling CV math. But this math should be the underscore one. And after that, just open a brackets. And inside this bracket, you need to give your type. Let's say unsigned char. And the size of the, the size of the image also you can specify. Let's start with 2 by 2. And after that, all you need to do is that assigning your pixel values respectively. Okay, maybe we can see how it's giving the result. Okay, now I assigned the first two value is the first row, and following two value is the second row, and it's give you the math type as output. After creating my math, I can call my determinant function, but maybe okay, it's better to see the result firstly. Maybe cout cv determinant, and after that just put input 1. But this is gonna give me error because my type is unsigned char. As you can see here, I get an error and it crashed. So maybe we can change unsigned char to float, and it's gonna calculate the determinant accordingly. But of course it will show me empty page because imshow does not support float type of maths. Okay, the determinant is -2, but how it's calculated maybe you already know, but or you don't know. Let's remember. Let's say this is my math input, which is defined with letters A, B, C, D. In our example, 1, 2, 3, 4, and is calculated for 2 by 2 matrices, A times D minus B times C. For example, this is our example. 1 times 4 minus 2 times 3 is equal to -2, which we found at the output equal to that one. For more complicated, bigger than 2 by 2 matrices, is calculated in this way, like this, and it's little more complicated according to this formula. For example, this one is equal to 0. So let's try this example. 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's try it. 6, 7, 8, and 9. But now our matrices is 3 by 3, and we can run the code. We are expecting it gives us 0 because also in this example it is 0. Okay, determinant is, you already know maybe, or we remembered again. It's working in this way, but where we can use this function in image processing. This is the most important part, is the determinant output tells us the input matrix is invertible or not. This is very critical because if invertible, so we can multiply with the invertible any matrix, so it's gonna give us the identity matrix. This is in the linear algebra operations is a very important case. So knowing the determinant is 0 or not is gonna give us an important information about the matrix. Also, in more detailed ways, maybe you can use this for other complicated neural networks operations, in some way I believe you will need determinant. So for this video I simply wanted to talk how it's working and yeah, and how it looks like. See you in the next videos.